Hello there, and welcome to the Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, tucked beneath something soft, or stretched out in the quiet dark, you chose this. You chose to slow down. And that means something. Whatever is waiting for you tomorrow can wait a little longer. Right now there is only this. A voice, a little science, and the vast, patient universe leaning in close. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Tonight we drift somewhere unexpected. The ocean. Not the fearful ocean, the deep, ancient, quietly astonishing one. And the strange, beautiful physics of the waves that move through it. Now, if you're ready, let's begin. There is a kind of silence that lives at the bottom of things. Not the silence of a room gone quiet. Something older. Something that has been waiting far longer than any of us. Tsunamis are born there not from wind, not from weather, but from the slow rearrangement of the earth itself. One vast stone plate pressing against another, then releasing. Picture the seafloor lifting not quickly, just rising across an area the size of a country. The water above has no choice but to respond. It accepts the energy, and then, with a patience that feels almost thoughtful, it begins to move. A tsunami is born not from storm but from the slow language of stone. The ocean listens to the earth, and then it carries what it heard, across thousands of miles, in perfect silence. A single grain of sand has lived many lives before it reached you. It may have been part of a granite mountain once. Rain and frost broke it loose. Rivers carried it, rolling it gently against other grains, smoothing the edges year by year. Eventually, it arrived at the sea, and the sea carried it further. Geologists have found individual grains of a mineral called zircon that are more than 4 billion years old, older than the oceans, older than complex life, small enough to rest on your fingernail. When you let sand fall slowly through your fingers, you are holding time, not a metaphor, the real thing, compressed into something almost weightless. The world is old in ways that feel soft, not heavy. Somewhere in the middle of the Pacific right now, a tsunami is passing. You would not know it if you were there. Floating on the surface, watching clouds, you might feel a very gentle rise and fall. A swell so gradual, so long from crest to crest, that your eye could not find its shape against the flat expanse of sea. And yet it is moving at the cruising speed of a commercial jet. All that energy, all that speed, and nothing to see. A ship passing directly over it would feel nothing worth noticing. The most powerful things do not always announce themselves. You are mostly water, not poetically literally. By molecule count, water is the overwhelming majority of what you are. The hydrogen in that water was forged in the first minutes after the Big Bang, nearly 14 billion years ago. It has been part of the universe for almost as long as the universe has existed. And right now, those ancient atoms are in you, carrying oxygen through your blood, cushioning your joints, filling the spaces between your cells. The ocean is not somewhere else. In some fundamental and measurable sense, the ocean is also here inside you, warm and still. You are not separate from the water that circles the planet. You are part of its long, unhurried journey. A tsunami slows as it approaches shore, and in slowing, it grows. Think of it like a breath drawn inward before it speaks. In deep water, the wave is fast and invisible, its energy spread thin across the full depth of the sea. As the floor rises beneath it, the wave feels the bottom. Physics makes a trade. Speed for height. The wave compresses, gathers itself. Every wave that has ever broken on a beach did this same thing. The same law, the same trade. The small wave and the great wave obeying identical mathematics. Physics does not make special exceptions. It simply applies the same gentle rules at every scale, to every body of water, everywhere. The Mariana Trench is deep enough to swallow the tallest mountain on Earth and still have miles of water above it. Hold that image, Everest, with all its ice and altitude, set at the bottom of the trench, its peak still more than a mile below the surface. That is where some of the world's most powerful earthquakes begin, where one plate dives slowly beneath another, and at the very bottom of that darkness, there is life. Small crustaceans, microbes, creatures adapted to pressures that would crush a submarine, living there quietly, as they have for longer than our species has existed. Life did not find the deep ocean and decide it was too much. It moved in, slowly, and made it home. You come from the same lineage of patient persistence. The Dart buoy system places pressure sensors on the ocean floor, listening in the dark for the passage of waves no human could feel. Picture them sitting quietly at the bottom of the Pacific, miles below the surface, in water so deep no light has ever reached it. When a tsunami passes overhead, even invisibly, the pressure above shifts. The sensor sends a signal upward. The buoy receives it. A satellite carries it to shore, and someone at a screen, perhaps with a warm cup of something, understands what is crossing the ocean hours before it arrives. Scientists built something that listens to the sea so carefully it can hear a wave no one can see. Attention, given faithfully over time, becomes a form of care. The word tsunami is Japanese. It means harbor wave, named not by scientists but by fishermen who returned from calm open water to find their villages changed. They had been out at sea when the wave passed. They felt nothing, but the harbor had received something they had not. Harbor wave, a name born from experience, from the specific geography of loss and return, not a technical term first, a human one, shaped by generations of people who needed language for something that kept happening. Words carry the memory of the people who first had to say them. Language and water share something. They both carry meaning across distances. They both shape the landscapes they move through. Indigenous communities across the Pacific encoded tsunami knowledge in stories passed down across hundreds of generations. Researchers studying these oral traditions have found accounts that match, when cross-referenced with geological sediment records, events that occurred centuries before European contact. The story and the sediment layer agree. The oral tradition and the tsunami deposit in the coastal earth point to the same approximate time. The stories were not mythology. They were data, held in the only archive that survived. Some of the most reliable knowledge in the world was never written down. It was spoken, carefully, to someone who would remember. Knowledge, like water, finds the paths that keep it alive. Even as you rest right now, the ground beneath your home is moving. Not in an earthquake, or at least, probably not, but in the tidal flexure of the Earth's crust, which rises and falls by a few centimeters twice daily in response to the gravitational pull of the moon. The solid Earth has tides, just as the ocean does. GPS instruments precise enough to measure this confirm it. The ground breathes, almost, with each passage of the moon above. The same forces that move the ocean move the rock you rest on. The moon does not make exceptions. You are not standing still tonight. You are being carried gently, continuously, by a planet that has never truly stopped. And somehow, in all of that motion, you are here, warm, still, resting. Scientists can watch a tsunami cross the Pacific before it arrives. There is something quietly extraordinary in that. A tremor happens beneath the sea. The water responds. And within minutes, people at monitoring stations around the world are watching the wave's path on a screen, tracking its speed, estimating its arrival, calculating what it will do when it reaches a particular shore. Not magic. Accumulated patience. Decades of instruments placed carefully in difficult places by people willing to wait years for data. The desire to understand something, not to control it, but simply to know it better, is one of the most human things there is. A lighthouse keeper in Portugal, in 1826, wrote in his log that the sea pulled back, not gently, abruptly. The harbor emptied faster than any tide. The seafloor appeared rocks, usually underwater, suddenly bare, fish stranded and confused. He had no framework for what he was seeing. He simply noticed, and he wrote it down. What he witnessed is called a drawback, the withdrawal of water that sometimes precedes a tsunami's arrival, as the trough of the wave reaches shore before the crest. He didn't understand it. He recorded it anyway, and that record survived. Sometimes the most useful thing is simply to notice and to remember. Stone monuments on the coast of Japan carry warnings placed there centuries ago. Some are inscribed with words that translate, roughly, as, "Do not build your homes below this point. The sea has come this far before." They were placed not as decoration, but as instruction, left by people who understood that their grandchildren might forget what they had witnessed, and that forgetting could cost lives. Some of those villages built above the old stones survived the 2011 tsunami. Some that built below did not. The stones were not superstition, they were data, carved into rock because paper doesn't last and memory is short, and the sea is patient in ways that human generations are not. Care extended toward people you will never meet. That is what a tsunami stone is, at its heart. Your breath right now moves in and out about 12 times a minute. In the open ocean, the longest tsunami waves pass a fixed point at intervals of an hour or more. The wave period, the time between one crest and the next, is so vast that what passes beneath a buoy is not a wave in any familiar sense. It is a slow, continental undulation, more like a tide than a wave, more like a breath than a crash. Your breath and the ocean's rhythm are not the same, but they share something structural, both a pressure moving through a medium, shaped by similar physics, serving similar purposes. The miracle of both is not drama, it is reliability, the faithful, automatic continuance of something that keeps you here. At the bottom of the ocean, there are fires, hydrothermal vents, cracks in the sea floor, where superheated water rises, carrying dissolved minerals that build into towers of rock. The water emerging can exceed 400 degrees Celsius and still remain liquid under the immense pressure of the deep. And around these vents, there is life. Tube worms as tall as a person, ghost pale crabs, microbial mats deriving energy not from sunlight, but from the chemistry of the earth itself. Scientists discovered these ecosystems only in 1977. Before that, it was assumed all life on Earth ultimately depended on the sun. One discovery changed the entire map of where life could exist. The most important surprises are the ones that expand what we thought was possible. A tsunami crossing the Pacific loses almost no energy along the way. Water is nearly incompressible. It does not absorb the wave's energy the way a cushion absorbs a blow. The energy is transmitted past through the ocean the way a vibration moves through a bell, the medium carrying the message without keeping it. Scientists have measured tsunami waves on instruments on the far side of the Pacific from their origin. The wave crosses an entire ocean, bends around islands, passes through channels, and arrives still recognizable, still the child of the earthquake that made it. It is like a message sent with such care that it survives the whole distance intact. Whatever you send into the world travels further than you know. The continents are moving beneath you right now. Europe and North America are separating at roughly the rate your fingernails grow, about 2 centimeters a year. The Atlantic is slowly widening, the Pacific slowly shrinking, the Himalayas still rising, incrementally, because the plate carrying India has not finished its long collision. Every earthquake is a small adjustment in this ongoing story, a catch released, a stress relieved, and sometimes, when that adjustment happens beneath the ocean, the water above becomes the messenger. The earth is not a fixed thing beneath you. It is a slow process, always mid-sentence, always becoming something slightly different from what it was. You are living on a story still being written. The ground beneath your home flexes today. The earth's crust rises and falls by a few centimeters twice daily, pulled gently by the moon's gravity, the way the ocean is pulled into tides. This is called the solid earth tide, and it is measured precisely by GPS instruments, sensitive enough to detect millimeter-scale changes in position. The same gravitational forces that raise the ocean also flex the rock beneath your feet. The moon does not distinguish between water and stone. It pulls at everything. You have been moving with the tides your whole life without ever feeling it. The universe has been including you in its rhythms all along. You simply haven't needed to know. The ocean has a circulation system that takes 1,000 years to complete one full loop. Cold, dense, salty water sinks in the polar regions and travels slowly along the ocean floor through the Atlantic, around the tip of Africa, into the Indian Ocean, eventually rising in the Pacific. One complete circuit takes roughly 1,000 years. Water sinking in the North Atlantic today will not return to the surface until somewhere around the year 3025. It will travel in the dark and the cold beneath an entire millennium of human history. You are standing at the end of a very long story every time you step into the sea. Some journeys are so vast they make the word journey feel small. Right now, without effort, the universe is holding you together. The atoms in your body are bound by electromagnetic forces, the same forces that hold every molecule of water in the ocean together. The same physics, at the scale of the atom, that governs how a tsunami moves through the sea. The fundamental forces of the universe do not change with scale. Gravity pulls you into your mattress with the same mathematics it uses to hold moons in orbit. The rules are consistent. They apply to everything. You are not a special exception to the laws of physics. You are an expression of them. A very complex, very temporary, very beautiful expression. The universe made the rules and then included you in them. That is not an accident. That is belonging. The Pacific Ocean is so vast that every piece of land on Earth would fit inside it with room to spare. Sit with that for a moment. Every continent, every island, every sandbar and mountain range, gathered together and placed inside one ocean basin, and still not enough to fill it. The Pacific is not large the way a mountain is large, by rising. It is large by being low, by being the place where water has collected over billions of years into the greatest body of liquid on the planet's surface. And across this basin, tsunamis travel, from Chile to Japan, from Alaska to Hawaii. The Pacific is not just an ocean, it is a transmission medium, carrying the Earth's geological conversations from one edge of the world to the other. The universe builds things on scales the mind can reach toward but never quite hold. Some tsunamis arrive not as a breaking wave, but as a quiet, persistent rise. The sea comes in, and keeps coming, not crashing, not dramatic, simply rising past the tide line, past the dunes, past the places water has never been in living memory. These slow tsunamis have wave periods so long the arrival feels less like a wave and more like an unusually determined tide. Witnesses have described the strangeness of watching water advance, without the sound of surf, just the sea, moving inland, quietly and with great purpose. Not everything large announces itself. Some of the deepest things move in silence. The quietest changes are often the most significant ones. Your ancestors navigated the open ocean by feeling waves with their bodies. Traditional Polynesian navigators learned to identify specific swell patterns not by looking, but by lying in the hull of a canoe and feeling the motion transmitted through the wood into their bones. They could distinguish the main ocean swell from the reflected wave bouncing off a distant island, and use that reflection to find land before it was visible. This skill, called wave piloting, was used for millennia to cross thousands of miles of open Pacific without instruments of any kind. The body as compass, the ocean as map. Some knowledge lives not in books, but in the trained sensitivity of a nervous system taught, over years, to listen. Water expands when it freezes, and that strange fact is part of why you exist. Most substances contract as they cool, becoming denser as solids. Water does the opposite. Ice is less dense than liquid water, which is why it floats. If ice sank instead, lakes and oceans in cold climates would freeze from the bottom up, solid all the way through. No liquid refuge beneath the surface for anything living. Instead, ice forms at the top and stays there. It insulates the water below. Life survives the winter underneath it, in the relative warmth of liquid that cannot freeze further. This one anomaly, water's single strange exception to the rules, kept the ancestors of your ancestors alive through glaciations that would otherwise have been fatal. A small quirk, held quietly in a molecule, changed everything. Every coastline on Earth is still being shaped right now by water, not only in storms. In the ordinary work of every ordinary tide, each rise lifting grains of sand, dissolving minute quantities of mineral from rock, carrying small things in and out of coastal marshes. Multiply that small work by twice a day, every day, for thousands of years. The result is the coastline as it is, not fixed, not finished, continuously becoming what it will be. The coastline is not a line, it is a verb. You are also in the middle of becoming, unfinished, still in process. The coast doesn't apologize for changing it, simply continues, responding faithfully to what the water brings. The moon is slowly leaving. At about 4 centimeters per year, the moon is spiraling away from the Earth. The same tidal drag it exerts on our oceans, gradually transferring energy outward, widening its orbit. In the distant past, it was much closer. The tides would have been enormous, crashing far inland, reshaping the early coastlines of a young planet. As the moon has moved away, it has gentled. The tides have become what they are now, still powerful, still shaping coastlines, but calmer, more like a rhythm than a disruption. The moon has been teaching the ocean to be quieter. It just takes an extremely long time. Some forces soften as they go. New ocean floor is being made right now, in the dark, at the bottom of the sea. At mid-ocean ridges underwater, mountain ranges longer than any on land, magma rises through rifts in the crust and solidifies as it meets cold water. New rock, added to the seafloor at a few centimeters per year. At the same time, old seafloor is being pulled back into the earth at subduction zones, recycled, melted, transformed, eventually returned. The ocean floor is the most thoroughly recycled surface on the planet. None of it is older than about 200 million years. It passes through state seafloor, subducted rock, magma, new seafloor, in a cycle with no beginning and no end. Change, held over long enough time, becomes a kind of constancy. A reef built by creatures smaller than your thumbnail has been sheltering coastlines longer than our species has existed. Coral polyps, each one no larger than a pencil eraser, secrete calcium carbonate skeletons around their soft bodies, building on the structures left by every generation before them. A healthy reef can reduce the height of incoming waves by as much as 70% before they reach the shore. The Great Barrier Reef has been growing, in various forms, for perhaps 500,000 years. Built by creatures with no plan, no awareness of scale, no knowledge of what they were making together. Small things, accumulated over enormous time, can become one of the most protective structures in the world. You have been accumulating too. Scientists still aren't entirely certain why some underwater earthquakes generate large tsunamis, and others, nearly identical in size, generate almost none. The type of fault movement matters. Vertical displacement sends more energy into the water than horizontal sliding. The depth of the rupture matters, the character of the sediment above the fault. But there are cases that don't fit cleanly. Earthquakes that generated larger tsunamis than their magnitude alone would predict. Others that generated smaller. The ocean keeps a few of its responses private. The edge of what is known is not a wall. It is a shoreline, and beyond it, the water is not empty. It is full of things not yet found. Even now, as you rest, your heart is sending a pressure wave to your fingertips. The heart contracts. A pulse of increased pressure moves outward through the arteries, diminishing slightly with distance, but still present, still doing its work when it arrives. If you press a finger gently to the inside of your wrist right now, you can feel it. A small, rhythmic arrival. The distant echo of your heart's last beat. The ocean carries the memory of distant earthquakes in its pressure waves. Your body carries the memory of your heart's last contraction in yours. Different scales, the same physics, fluid and wave and faithful transmission. You are, in some small and genuine sense, oceanic. Beneath the ocean, there are mountains no one has ever seen. Not because they are hidden by darkness alone, though they are, but because the deep seafloor was, until very recently, as unknown as the surface of another planet. The first detailed maps were not produced until the mid-20th century, when sonar technology finally allowed ships to measure depth systematically across wide swaths of open ocean. What those maps revealed was extraordinary, in the quietest way. Mountain ranges, vast plateaus, canyons deeper than anything on land. The mid-ocean ridge, the longest mountain range on Earth, running for 40,000 miles along the seafloor, taller than the Alps in places, never once breaking the surface. Discovered within living memory. Still mostly unseen. The world is still revealing itself. We are still in the early chapters of understanding the place we live. Some trees on tsunami-affected coastlines have been standing for centuries. Old enough to have witnessed more than one major event, old enough that the wood at their core was growing when the coastline looked different, when the people nearby spoke differently, when the world's maps were still guessing at the shape of the continents. Scientists have studied the chemistry of their rings, changes in growth, traces of salt stress looking for the years when the sea came inland. The trees remember, in their rings, what happened to them. Good years wide, difficult years narrow, unusual events leaving a shift in color, in chemistry, in the texture of the growth. The trees are keeping records, quietly, without being asked. The smell of the ocean is a form of chemistry sent into the air. That particular scent, salt, and something alive, something that opens the chest and steadies the breath, includes a compound called dimethyl sulfide, released by phytoplankton when they are disturbed by wave action. When surf breaks, the organisms near the surface are jostled. The compound rises, the wind carries it inland, and something in you responds some ancient recognition that the ocean is near. Dimethyl sulfide also contributes to cloud formation over the open sea. The ocean, through its smallest inhabitants, helps make the clouds above it. The clouds shape the weather shapes the waves. The waves disturb the plankton further. Your body knows the ocean before your mind does. The ocean floor is the Earth's slowest diary. Particles fall continuously onto the abyssal plain, the remains of dead plankton, mineral grains, dust blown from continents. This accumulates at roughly a centimeter every 1,000 years. Scientists take core samples, long hollow tubes lowered from research ships, and read the layers like pages. The chemistry of microscopic shells tells them the water temperature when the creature lived. The ratio of isotopes tells them the extent of polar ice at the time, and in some cores, thin layers of coarser sand mark the passage of ancient tsunamis material, deposited in a brief moment of disturbance, then covered again by the patient drift of ordinary time. A catastrophe, buried beneath the slow work of centuries. Every layer is a year or a millennium of the Earth telling the truth about itself. In 1958, a single wave in Alaska climbed higher than the tallest skyscraper ever built. A rock slide fell into Lituya Bay, a narrow fjord in southeastern Alaska, and the displaced water surged upward along the valley walls. The trimline, the boundary between stripped rock and surviving forest, reached more than 500 meters above sea level, taller than any building humans have constructed, carved in a single night by a single wave. And yet one boat anchored in the bay that night survived. Howard Ulrich and his son were lifted by the wave, carried over the spit of land at the bay's entrance, and lived. The same wave. Different outcomes depending on where you were. The bay has been quiet since. The forest has grown back. The trimline remains a watermark, left by something that reached toward the sky. A wave is not water moving forward. It is a pattern moving through water. When a wave passes, the water molecules move in small circles, rising as the crest approaches, falling as it passes, returning almost exactly to where they started. What travels is not the water, it is the shape. The energy passing through the ocean, the way a ripple passes through a field of grass without carrying the grass anywhere. You can see this with a seabird sitting on the surface. It bobs, rising and falling, and returns to roughly the same place. The wave passes beneath it, like a thought moving through a still mind. A wave is not a thing. It is a process. And so, in some quiet sense, are you a pattern of energy moving through matter, taking a particular shape for a particular time? There are people whose job is to listen to the ocean at night. Hydrophone operators and oceanographic researchers spend hours reviewing recordings from the deep, the low rumbles of distant earthquakes, the songs of whales traveling across entire basins, the hiss of underwater volcanic activity. Most of what they hear is familiar, known, filed, but occasionally something arrives that has no immediate explanation, a sound too large, too strange, too unlike anything catalogued before. The ocean still produces sounds scientists haven't fully identified, low-frequency signals of unknown origin, recorded and studied and not yet completely assigned to a source. The ocean is still, in this very literal sense, telling us things we haven't understood yet. We are still learning to hear it. Every wave that has ever broken on a beach began somewhere else entirely. As a ripple raised by wind on the open ocean, perhaps thousands of miles away, it traveled, growing and organizing, losing the choppiness of the wind-disturbed surface and settling into long, clean swells. As it traveled, it sorted itself the most energetic, longest wavelength parts, moving fastest, arriving at distant shores first. The last moment of that wave, the breaking, the curl, the hiss of foam on sand is the final act of a journey that may have lasted days. That moment of meeting the shore is the only visible moment it ever had on land. Everything before it was out at sea, unwitnessed, traveling. The arrival is real, even when the journey was invisible. A date written in Japanese from the year 1700 unlocked a silence in North American geology. Researchers searching historical records found meticulous accounts from multiple coastal villages in Japan describing unexpected waves arriving in the early morning of January 27, 1700, with no local earthquake to explain them. Working backward from the wave's travel time and pattern, scientists calculated the source, the Cascadia subduction zone, off the coast of the Pacific Northwest. At approximately 9 in the evening of January 26, a wave crossed the Pacific. A record was kept in careful script. 3 centuries later, that record gave a precise date to an earthquake no one on the North American coast had instruments to measure. Information does not always disappear. Sometimes, it simply waits, quietly, in a place you haven't thought to look. Right now, somewhere on the sea floor, a pressure sensor is listening. It sits in absolute dark at a depth that would crush any unprotected thing, measuring the weight of miles of water above it. Most of the time, nothing unusual to report. The data streams upward through an acoustic link, received by a buoy at the surface, transmitted by satellite to a monitoring center, processed, filed. But the sensor keeps listening, because that is its purpose. Not to record the dramatic moments, which are rare, but to maintain the continuous, patient attention that makes it possible to recognize one when it arrives. Attention, maintained faithfully over time, is one of the most powerful things in the world. Even now, someone is keeping the quiet vigil that safety requires, so that you can rest. At the bottom of the Mariana Trench, the pressure is roughly 1,000 times greater than the air around you right now. And yet, small crustaceans have been found there in surprising numbers. Microbes metabolize in the cold and the dark, doing the quiet biochemical work of being alive under conditions that would destroy almost every instrument we have sent to investigate them. Scientists still don't fully understand how their cell membranes maintain integrity under such pressure. The chemistry is unusual. The adaptations are still being studied. Life did not look at the most extreme environment on Earth and decide it was too much. It moved in, adjusted, continued. You are the product of 4 billion years of that same approach. A major earthquake can release more energy in minutes than a continent uses in electricity for a month. Most of that energy converts almost immediately to heat the grinding of rock against rock, generating friction along the fault plane. A small fraction becomes the seismic waves that shake the ground. A smaller fraction still transfers into the water above and becomes a tsunami. The wave that crosses an ocean is the quietest expression of the earthquake's energy, the most traveled, the most patient. The rest stays close, heating rock, shaking ground briefly, then dissipating into the vast thermal mass of the Earth's crust. The Earth absorbs its own force quietly. What we call a disaster is, from the planet's perspective, simply exhaling. Most of a tsunami's energy in the open ocean is invisible, carried not at the surface, but through the entire depth of the water. Imagine a sound wave traveling through a wall. The vibration is not just at the surface, it moves through the whole thickness of the material. A tsunami in deep water is similar. The entire column of water, miles deep, participates in the wave's passage. This is why so little energy is lost over long distances. There is so much water involved in carrying it that the energy has nowhere to go. What was spread through 4 miles of depth suddenly compresses into 20 feet of it at the shore. The column shortens. The energy rises. What was invisible becomes visible. What was traveling becomes arriving. Right now, the oxygen entering your lungs may have been made in the ocean. Phytoplankton, microscopic algae, individually invisible, collectively visible from space as blooms of green across the sea, produce roughly half of the oxygen in Earth's atmosphere. Not the rainforest alone. The ocean, through its smallest inhabitants, generates half of every breath you take. When waves break, they disturb the surface. The phytoplankton are jostled, but the photosynthesis continues. The oxygen rises into the atmosphere, mixes, travels, and eventually, perhaps days or weeks later, reaches wherever you are lying right now. The ocean has been breathing for you since long before you knew what an ocean was. You are being kept alive, right now, by the sea. The Sanriku coast of Japan has been struck by tsunamis in 1896, 1933, 1960, and 2011, and people have returned each time, not from ignorance. The communities of the Sanriku coast know the ocean is dangerous. They know it will come again. And they know, also, that it is home, that the relationship between a people and their particular piece of coastline is not simply a matter of risk calculation. It is identity. It is ancestry. It is the smell of a specific harbor in the early morning. Life in the presence of known risk, does not always retreat. Sometimes it learns the shape of the danger and builds just above the waterline with full knowledge and with eyes open. There is a kind of courage in that which asks nothing of us except recognition. The great ocean conveyor belt moves slower than a river and regulates the climate of entire continents. Cold, dense water sinks in the polar regions and travels along the ocean floor at speeds too slow to feel. One complete loop takes roughly 1,000 years. And yet this movement is responsible, in part, for the mild climate of Western Europe, the Gulf Stream delivering tropical warmth to latitudes that would otherwise be far colder. London shares a latitude with parts of Canada. The ocean is the reason they feel so different. Scientists are watching whether a warming climate is altering the density differences that drive this circulation. They aren't certain yet. The system responds on timescales of decades and centuries. The ocean takes its time giving answers, the way it always has. There are submarine landslides on the ocean floor, larger than entire countries. The Storegga slide, which occurred off the coast of Norway roughly 8,000 years ago, involved the movement of several thousand cubic kilometers of sediment across the seafloor. The resulting tsunami crossed the North Sea and struck the coastlines of Norway, Scotland, and Iceland with waves many meters tall. At that time, a low-lying plain called Doggerland connected Britain to mainland Europe inhabited, lived upon, perhaps partially inundated by that wave. Scientists still aren't entirely certain what triggered it. Warming climate, an earthquake, the decomposition of methane hydrates in the sediment. The record is incomplete. The deep past is not closed. It is written in a language we are still learning to read. A tsunami arriving at shore can carry the smell of the deep ocean with it. The surge brings water from far below, cold, mineral-rich, carrying compounds that don't usually reach the surface. Witnesses to certain tsunami events have described an unusual smell arriving with the water. Not the familiar salt of the shoreline, but something older, something from further down. The ocean briefly wearing its depths on the surface. The sea has layers that almost never mix. The deep and the shallow live in different chemical worlds, separated by temperature and density. A tsunami is one of the rare forces that briefly collapses that boundary. Even the ocean's most hidden parts occasionally come to the surface. Nothing stays sealed forever. Your heartbeat is a pressure wave. The heart contracts. A surge of increased pressure travels outward through the arteries, reaching your fingertips the way a wave reaches a far shore, diminished slightly by the journey, but still present, still doing its work. Ancient Chinese physicians pressed specific points along the wrist and read the character of the pulse wave to understand the state of the body's interior. They developed, over centuries, a vocabulary for what they felt qualities of rhythm, depth, strength. They were reading pressure waves traveling through fluid. The same physics as a tsunami, a different scale, a different medium. The ocean carries the memory of distant earthquakes in its pressure waves. You carry the memory of your heart's last beat in yours. Scientists still aren't entirely certain why some underwater earthquakes generate large tsunamis, and others, nearly identical in magnitude, generate almost none. The angle of fault movement matters. The depth of the rupture matters. The character of the sediment above the fault. But there are earthquakes that generated larger tsunamis than their magnitude alone would predict, and others that generated smaller. The models are good. They are not complete. The ocean keeps a few of its responses private. Not knowing is not the same as there being nothing. It is simply where the next knowing begins, at the shoreline of what has already been understood, looking out. A date recovered from Japanese records gave a silent North American earthquake its exact time. On the morning of the 27th of January 1700, coastal villages in Japan recorded unexpected waves with no local earthquake to explain them. Researchers working centuries later calculated the source the Cascadia subduction zone, off the Pacific Northwest coast, rupturing at approximately 9 in the evening of January 26. They determined not just the date but the approximate magnitude and the length of the fault that moved. Indigenous oral histories from the Pacific Northwest, long documented, not previously connected to a specific geological event, suddenly had a date. The stories were not mythology. They were eyewitness accounts of the same night, preserved across 300 years. The wave remembered. The record remembered. The stories remembered. Memory is more durable than we tend to assume. A reef can reduce the height of an incoming wave by as much as 70% before it reaches the shore. The rough, complex surface of healthy coral dissipates energy through friction and turbulence, breaking the organized motion of the wave into smaller, less coherent movements. For a tsunami, the effect is real but incomplete. A large wave carries far more energy than a reef can fully absorb. But even a partial reduction in height changes how far water travels inland and how much force it carries when it arrives. The polyps building the reef have no awareness of what they are making together. Each one simply secretes its small calcium carbonate skeleton and continues, generation by generation, century by century. Small, continuous acts of simply being what you are can become one of the most protective structures in the world. The seafloor beneath the ocean is younger than the ground beneath your feet. The oldest oceanic crust is only about 200 million years old, formed during the age of dinosaurs. The continental crust you live on is far older. Rocks in northern Canada and Western Australia have been dated to more than 4 billion years. The cratons, the ancient, stable cores of the continents, have been sitting at the surface since before complex life existed. The ocean floor, by contrast, is continuously made and remade. It does not accumulate history the way the continents do. It transforms, passes through states, begins again. The ocean rests on a surface that is always in the process of becoming something else. Change, sustained long enough, becomes its own kind of permanence. On the night of the 26th of January 1700, people were sleeping on the coast of what is now Oregon. They had lived there for thousands of years, the ancestors of the Tillamook, the Silex, the Coquille. They knew the coast intimately, the seasonal patterns of fish, the behavior of tides, the particular sounds the sea made before certain weather. What they did not know was what was building beneath their feet. The fault released. The shaking lasted several minutes, long enough to understand something fundamental was happening. Then the sea withdrew. Then it returned. Their accounts survived. When the Japanese record gave those accounts a date, the stories became what they had always been: testimony. Eyewitness record of a real geological night. The stories were always true. It simply took longer for some people to recognize them as evidence. The colors of the ocean deepened toward darkness, in a sequence as orderly as a spectrum. Red light is absorbed within the first few meters, then orange, then yellow. Green persists longest, which is why great depths often appear green before they turn blue. Below about 200 meters, photosynthesis becomes impossible. Below 600, light is essentially gone. Below 1,000 meters, it is completely, permanently dark. And below that, in the vast, deep darkness, is not an absence. It is a condition, a permanent one that has characterized these environments for as long as they have existed. Life adapted to it by inventing its own light. Bioluminescence is extraordinarily common at depth. The majority of deep-sea fish can produce it. The ocean went dark and made its own glow. Darkness is not an ending. It is a condition that life finds interesting. Some Pacific islands were born from the same forces that generate tsunamis. The Hawaiian Islands sit atop a volcanic hotspot, a plume of unusually hot mantle material rising through the overlying plate, erupting as lava on the sea floor, building upward through miles of water until it breaks the surface and becomes land. As the Pacific Plate moves slowly northwest over the hotspot, a chain of islands is created, each one built from the seafloor over millions of years, then gradually eroding back toward the sea once its volcano goes dormant. The same tectonic restlessness that produces earthquakes and tsunamis also builds islands. The same boundary of plates, the Ring of Fire, is responsible for both the creation of land and the waves that sometimes wash across it. Destruction and creation share the same address. They always have. Wave buoys float on the ocean right now, measuring the rise and fall of the surface with instruments sensitive enough to detect the passage of a distant tsunami. These buoys have been out there through decades of storms, struck by debris, fouled by marine growth, battered by weather. Many are still transmitting. They measure ocean temperature, salinity, wave height. They contribute data to models that help scientists understand how the ocean is changing. They are, in a sense, the ocean's nervous system. Sensors embedded in the medium, translating the physical world into information, making it possible to respond rather than simply be moved. You have a nervous system too, doing the same fundamental thing, paying attention, translating, making response possible. Attention is the oldest technology. The universe has been practicing it for as long as there have been things to notice. The ocean surface is not flat, it reflects the shape of the seafloor beneath it. Even on a completely calm day, the ocean surface bulges and dips slightly, following the topography below. Underwater mountains attract slightly more water above them, raising the surface by a few meters. Deep trenches pull the surface gently down. These differences are too small to see from a ship, but visible from space, satellite altimeters detect them, and scientists have used this technique to map the broad shape of the seafloor without descending to it. The surface carries the signature of the deep. What is hidden below is written, faintly, in what is visible above. Everything has a signature. Every hidden thing leaves a trace at the surface, if you have instruments sensitive enough to read it. Ancient Greeks recorded unusual waves reaching the Mediterranean coast, events modern geology has since confirmed. In 365 CE, an earthquake off Crete generated a tsunami that struck Alexandria in Egypt, carrying ships inland. The historian Ammianus Marcellinus described the sea withdrawing, vessels stranded, the water returning in a great surge. Earlier still, the eruption of Thera modern Santorini around 1600 BCE sent waves across the eastern Mediterranean that may have reached coastlines from Egypt to Greece. The Mediterranean, which we tend to think of as a gentle, civilized sea, has a geological character as restless as any ocean. The sea that gave us Homer also occasionally sent waves across its surface that changed the civilizations on its shores. History and geology are the same story, told at different speeds. The boundary between the ocean and the atmosphere is not a line, it is a conversation. Water evaporates from the surface into the air. Gases from the air dissolve into the water. Carbon dioxide enters the ocean and is absorbed by phytoplankton or dissolved into carbonic acid. Oxygen produced by phytoplankton leaves the water and enters the air. This exchange happens at every point on the ocean's surface, simultaneously, all the time. The ocean has absorbed roughly 30% of all the carbon dioxide released by human activity since the Industrial Revolution, slowing the pace of atmospheric warming at the cost of gradually acidifying its own water. The ocean has been absorbing our exhaust, quietly, without complaint. What we put into the air, the ocean takes in. We are in conversation with it, whether or not we have been listening. There is a bay in Alaska where the mountainside still shows what the water did. Lituya Bay is narrow and steep, a long fjord carved by glaciers into the mountains of southeastern Alaska, opening to the Gulf through an entrance barely half a mile wide. In 1958, a rock slide fell into the water at its head, and the displaced water surged upward along the valley walls. The trimline, the boundary between stripped rock and surviving forest, is still visible today. New growth has filled the lower slopes, but the shape of what happened is preserved in the landscape. The bay is still geologically active. The glaciers at its head are still retreating, destabilizing the valley walls. The record is not finished. The landscape is still responding to forces that have been operating for thousands of years. We are always living in the middle of a story that started long before us. Water is one of the most common molecules in the universe, not just on Earth. Water has been detected in molecular clouds, in the atmospheres of other planets, in comets, in the dust surrounding distant stars still forming. The hydrogen and oxygen that make it are among the most abundant elements in the cosmos. Given enough time and the right conditions, water forms almost inevitably. The water in your cells arrived on this planet partly from space, delivered by comets and asteroids in the period of heavy bombardment early in the solar system's history. The hydrogen in that water is nearly 14 billion years old, formed in the first minutes after the Big Bang, older than any star that currently exists. You are not just made of the Earth. You are made of the universe's longest chemistry experiment. The speed of sound in seawater is about 4.5 times faster than in air, and blue whales use this to call across entire ocean basins. A blue whale's low-frequency call, produced at depths where it enters the SOFAR channel, a layer of minimum sound speed where sound becomes acoustically trapped, can travel thousands of miles with remarkable efficiency. Scientists have documented that whale populations on opposite sides of ocean basins show similarities in their vocalizations, suggesting individuals separated by vast distances may be, in some sense, in acoustic contact. Communication across distances so vast that meeting is impossible. A voice sent into the ocean, and perhaps received somewhere beyond imagination. The ocean is full of voices. Not all of them are silent. A GPS satellite can detect the passage of a tsunami by the way it flexes the ground. As the wave moves through the ocean, the weight of the water shifts slightly, and the crust beneath it responds, rising and falling by a centimeter or two. GPS stations on land measure their own position with millimeter-level precision. When the ground flexes with the wave's passage, the data changes. Scientists read the change and understand what is crossing the ocean. GPS was built for navigation. It became, also, a way of listening to the ocean's effect on the solid Earth, detecting from space the subtle breathing of the crust as a wave passes through. Every tool we build for one purpose eventually becomes useful for another. Ingenuity is patient that way. Tsunami stones in Japan have been standing for centuries, carrying warnings for people not yet born. The most well-known is in Anayoshi village, inscribed with words translating roughly as, "Do not build your homes below this point. High dwellings ensure the happiness of descendants." The stone was placed after a tsunami in 1933. The village built above it survived 2011. Villages below the line did not fare as well. These stones are not monuments. They are a technology simple, durable, requiring no power, no network, no maintenance. Just rock and words, and the accumulated understanding of people who knew that memory is short and the sea is patient. How do you tell people something important when you cannot know what language they will speak or what world they will live in? You write it in stone, and you trust that someone will read it. The ocean surface is always moving, and the deep is almost perfectly still. A storm can tear the surface into chaos, breaking waves, spray, chop in every direction. And a few meters below, the turbulence diminishes. Deeper still, only the vast, slow currents of the thermohaline circulation move, in rhythms measured in decades and centuries. The storms that rage at the surface barely reach the deep. The ocean has depths that weather cannot touch. You have depths like this too. Beneath whatever weather is passing through your mind tonight, something quieter persists. Something the day's storms do not reach. Something that has been continuous through everything still and patient and available. Right now your body is finding its way toward that depth. It knows the path. It has made this journey every night of your life. The Tohoku earthquake of 2011 shifted the Earth's axis and shortened the day. The rupture moved the seafloor upward across an area roughly the size of Connecticut, redistributing mass in a way that altered the planet's rotation. The Earth's axis shifted by perhaps 17 centimeters. The day shortened by approximately 1.8 microseconds, detectable only by atomic clocks precise enough to measure the planet's rotation to extraordinary accuracy. No one felt the axis move. No clock on any wall showed the change, but it happened. An earthquake changed the length of a day. The Earth is not rigid, it is responsive. It shifts, adjusts, and continues as living things do. An underwater mountain can redirect a tsunami the way a stone redirects a stream. When a tsunami encounters a seamount, an isolated volcanic mountain rising from the abyssal plain, the wave bends around it, reflects from it, is focused by it, into beams that travel in directions determined by the mountain's shape. Some coastlines receive less energy because a seamount deflected it away. Others receive more because the mountain focused it toward them. There are thousands of seamounts in the Pacific alone, many uncharted, each one quietly shaping the path of every wave that passes, without drama, without credit, simply by being what they are, in the place they happen to be. Presence is a kind of influence. You don't have to do anything dramatic to change the path of things. Every enclosed bay has a natural frequency, and a tsunami that matches it can make the water climb far higher than expected, like a guitar body, amplifying certain notes while dampening others. A bay resonates at a particular period. If a tsunami arrives with a wave period close to the bay's natural frequency, each successive surge adds to the last. The water builds. It rises far beyond what the open ocean wave would suggest. This is why some harbors suffer dramatically from tsunamis that cause little damage elsewhere on the same coastline. The shape of the place, more than the size of the wave, determines what happens inside it. You are also shaped by your particular geometry. Some things move you deeply, some pass through. The same event, different people, different resonances. That is not a flaw. That is how resonance works. Deep-sea sediment cores contain a continuous record of Earth's climate, stretching back millions of years. Microscopic shells, foraminifera, tiny single-celled organisms that live at the surface, sink when they die, and accumulate on the abyssal plain, preserve in their chemistry the temperature of the water when they lived, the extent of polar ice, the concentration of carbon dioxide in the atmosphere. Layer by layer, millimeter by millimeter, the ocean floor has been keeping notes. The foraminifera did not know they were keeping records. They simply lived and died, each generation adding its shell to the accumulation below. Every small life, lived faithfully, leaves a record. The ordinary moments matter more than they appear to while they are happening. After a major earthquake, the Earth keeps talking to itself for months. The fault that ruptured is now in a new configuration. The surrounding rock adjusts, settling into its new arrangement through a series of smaller movements called aftershocks that can continue for months, sometimes years. Each one a small readjustment, a tiny settling, the geological equivalent of a long, slow exhalation after something large has passed. These aftershocks are not the earthquake trying to happen again. They are the Earth finding its new equilibrium. They follow statistical patterns that scientists study carefully, each one carrying information about the fault's structure. about how the stress has redistributed. The Earth processes its large events slowly, in stages. It does not move from rupture to stillness immediately. You are allowed to take time too. Some communities mark the memory of past waves in the placement of their homes. Across the Pacific, wherever the sea has shown what it can do, communities have developed technologies for remembering. Stone markers, elevated memorial grounds, entire villages positioned on hillsides above the waterline, the fishing harbor below, the homes above, the distance between them calibrated by the knowledge of what the sea has done before. Some mark the memory ceremonially, annual rituals, prayers offered to the ocean, not from fear, but from the understanding that the relationship between a coastal people and the sea is long and complex and requires acknowledgement. All of these are ways of holding knowledge in the community across time, of making sure that what one generation learned does not have to be relearned by the next. Memory, in this sense, is not about the past. It is about the future. A wave in the open ocean is a pattern moving through water, and you are something similar. The atoms in your body are ancient and will outlast you enormously. They were here before you and will be here long after. What is distinctly you is the pattern, the specific, temporary, unrepeatable arrangement of matter, carrying information forward through time. The wave travels. The water mostly stays. What persists is the organization, the shape. Physicists call this phase velocity, the speed at which the pattern moves, which can be entirely different from the speed at which the material carrying it moves. You travel through time. The atoms mostly stay cycling through you, entering and leaving, none of them permanent. What persists is the pattern. And the pattern is real. The pattern is, in every meaningful sense, who you are. In the aftermath of a tsunami, coral has been found growing around the debris the wave left behind. Wreckage deposited in the ocean becomes substrate. Organisms colonize it. Algae, invertebrates, and eventually coral polyps settle on surfaces that were not there before. Over years and decades, the coral grows around and over the debris, incorporating it, building on it, laying down calcium carbonate on top of what the wave left. Scientists studying post-tsunami reefs have found coral colonies growing on recognizable human artifacts. Sections of structural steel, fragments of concrete, the reef slowly writing over the record of destruction with the record of life returning. Recovery does not erase what happened. It grows over it, through it, around it. The record remains, underneath. And life builds on top anyway, not because the difficulty didn't matter, but because building is what life does. The moon and sun align twice a month to produce tides higher and lower than usual. At new moon and full moon, their gravitational forces combine. The sea springs higher at the shore, the low tides go lower. These are called spring tides, from the old sense of the word, to spring up, to surge. At the quarter moons, the forces partially cancel, and the range between high and low is at its smallest. This cycle has been governing the behavior of every tidal ecosystem on Earth since the moon settled into its orbit. Organisms time their reproductive releases to the spring tides. The timing is not learned or chosen. It is written into biology by hundreds of millions of years of evolution in a tidal world. The moon is not separate from life. It is woven into it, into the timing of reproduction, the rhythm of behavior, the architecture of ecosystems. You too are subject to forces you have never needed to name. Less than 20% of the ocean floor has been mapped in meaningful detail. More of the surface of the moon has been mapped. More of Mars. More of Venus. The largest environment on Earth, covering more than half the planet's surface, remains mostly unseen. Not because it is unimportant, but because it is difficult. The pressure, the darkness, the sheer scale of the task. And with each new section mapped, there are discoveries. New seamounts, new vent fields, new canyon systems, new evidence of processes that weren't anticipated. The seafloor keeps being more complex, more varied, more interesting than the extrapolation suggested. The unknown is not empty. The unknown is full of things. We are mapping the floor of our own home ocean and finding, consistently, that home is stranger and richer than we knew. There are parts of the deep ocean where the water hasn't touched the surface in over 1,000 years. It sank in the North Atlantic, cold, dense, oxygenated from its time at the surface, and descended into the deep. It began its long journey along the ocean floor, moving at speeds too slow to feel, covering distances too vast to walk, in darkness too complete to imagine. That water was at the surface during the Song dynasty, during the height of the Crusades, before the printing press, before the Americas appeared on European maps. Scientists measure its age using carbon isotopes. Radioactive carbon decays at a known rate, and water cut off from the atmosphere accumulates its age in its chemistry. Ancient water, patient water, moving in the dark toward a surface it will not see for centuries. Whatever you have put into the world is in circulation. It does not disappear. It may take time to return. The SOFAR channel traps sound in the ocean the way a valley traps fog. At roughly 800 meters depth, the speed of sound in water reaches a minimum. Sound traveling through water bends toward regions of lower speed, and in the SOFAR channel, sounds from above and below are bent back toward the center, becoming trapped, propagating horizontally with extraordinary efficiency. A sound produced there can travel across an entire ocean basin and still be detected on the far side. Whales exploit this. Their low-frequency calls enter the channel and travel thousands of miles. Whether individual whales are communicating across entire ocean basins, whether a call sent from one side is received and responded to from another is still debated. Scientists aren't certain how far the acoustic connection truly extends, but the channel exists. The ocean built a structure, by accident of thermodynamics, that carries voices over distances that seem impossible. The capacity was there before anyone knew to use it. Coastal communities across the Pacific have oral traditions describing waves that came without warning and changed the land. These stories exist in cultures separated by thousands of miles in Japan, Indonesia, the Pacific Islands, coastal South America, the Pacific Northwest. They share certain features across those distances. The sea pulling back, the wave arriving, the land changed afterward, people who ran to high ground surviving, people who stayed, not surviving. Researchers have found that some of these accounts, when cross-referenced with geological sediment records, point to the same approximate events. The story and the sediment layer agree. Someone loved people they would never meet, and sent that love forward through time in the form of a story, hoping it would arrive intact. Some of it did. Right now, a pressure sensor on the Pacific floor is listening. It reports, most of the time, nothing unusual. The data streams upward through an acoustic link to a buoy at the surface, transmitted by satellite to a monitoring center, processed, filed. Nothing to report. The ocean is doing what the ocean does. But the sensor keeps listening, not for the dramatic moments, which are rare, but maintaining the continuous, patient attention that makes it possible to recognize one when it arrives. Each part of the system doing its quiet, undramatic, essential thing, together making it possible for someone on a far shore to have a little more time. Technology, at its best, is just attention made systematic. Even now, someone is keeping watch, so that you can rest. The longest tsunami ever recorded in travel time crossed the Pacific in less than a day. 22 hours of almost nothing visible. A pressure wave moving at the speed of a jet, crossing the largest ocean on Earth, arriving at the far shore so quietly that instruments had to be carefully calibrated to distinguish it from the ordinary background motion of the sea. Think of what happened in those 22 hours. People slept and woke, meals were made, the sun rose on one coast and set on another, ships passed over the wave without noticing, birds rested on the surface above it, feeling nothing unusual. The wave crossed all of that. Underneath, silent, carrying its energy with the patience of something that does not know it is being waited for. Bioluminescent plankton can make tsunami-disturbed water glow faintly in the dark. In certain ocean conditions, when the water is rich with dinoflagellates, microscopic organisms that produce cold light, when disturbed wave action triggers flashes of blue-green luminescence. In normal conditions, breaking surf in such water glows softly with each wave. When a tsunami moves through water rich with these organisms, the disturbance is vast. Some witnesses have described an unusual glow arriving with the surge, the sea briefly lighting itself from within. Not a warning, not a signal for anyone, just the ocean's own quiet chemistry, made visible because something large passed through. The world lights up sometimes when it is moved, not always in ways that last, but the light is real. In many Pacific languages, the word for wave carries within it the sense of both arrival and departure. In English, we tend to think of a wave as something that comes, it arrives, breaks, retreats, coming and going as separate acts. But in some Polynesian and Melanesian languages, the wave is understood as a single continuous event, arrival, and withdrawal as two phases of one motion, held in one word. This is, in fact, physically accurate. The crest and the trough are parts of the same wave. The water rises and falls as one unbroken movement. The language captures the physics more honestly than the intuition does. The things that come and go in a life, people, seasons, periods of difficulty and ease, perhaps they too are more accurately understood as single continuous events than as separate arrivals and departures. The wave does not leave, it completes. Every coastline on Earth is still being shaped right now, in this moment, by water. Not only in storms, in the ordinary quiet work of every ordinary tide, each rise lifting grains of sand, dissolving trace quantities of mineral from rock, carrying small things in and out of coastal marshes. That small work, multiplied by twice a day, every day, across thousands of years, produces the coastline as it is. Not fixed, not finished, always mid-sentence, always in the process of becoming what it will be next. The coastline is not a place that was made, it is a place that is being made. You are also still being made. The same slow, faithful forces, the things that come and the things that go, are still shaping you. That is not incompleteness, that is how everything works. You are mostly empty space, and yet here you are, warm and solid and entirely real. The nucleus of an atom, where most of the mass is concentrated, is extraordinarily small relative to the atom as a whole. If a hydrogen atom were expanded to the size of a football stadium, the nucleus would be roughly the size of a marble at the center. Everything else would be empty space. You are, at the atomic scale, almost entirely nothing. The solidity you feel, the surface beneath you, the weight of your own body is not solidity in the philosophical sense. It is electromagnetic force, the repulsion between electron clouds that will not overlap, the universe insisting on a boundary that feels, to your nervous system, like something real. And it is real, held together by forces so fundamental they have no simpler explanation beneath them. The almost nothing is enough. It has always been enough. The ocean is estimated to contain not one perfectly still molecule of water. At the atomic scale, thermal motion means that even in the coldest, deepest, most apparently still water, molecules move at hundreds of meters per second, colliding billions of times each second in ceaseless thermodynamic activity. Above that scale, The currents move. The tides pulse. The deep circulation turns its thousand-year loops. Waves cross the basins. The bioluminescent organisms flash and dim. At every scale simultaneously, from the molecule to the ocean basin, the water is doing something. And somehow, in all of that motion, there is peace. Motion and stillness are not opposites. The deepest calm is not the absence of movement. It is movement so vast and continuous it becomes, to the creature resting within it, indistinguishable from stillness. The Earth's interior is still cooling from the moment of its formation. When the Earth formed, roughly 4.5 billion years ago, it was a molten body heat from the collision of countless smaller bodies, from the decay of radioactive elements in the rock. Over billions of years, that heat has been slowly escaping, conducted upward, carried by the convection of the mantle, released at volcanoes and mid-ocean ridges and hydrothermal vents. The heat that drives plate tectonics, the moving plates, the spreading ridges, the subducting slabs, the earthquakes, the tsunamis, is largely heat left over from the formation of the planet. The warmth beneath your feet is ancient. It is the memory of a collision. The Earth has been exhaling it since before it had an ocean. We are living inside a memory of fire, slowly cooling. The ocean has sounds in it that scientists have recorded but not fully explained. The NOAA hydrophone arrays, underwater listening systems, originally deployed during the Cold War, have been recording the ocean continuously for decades. Most of what they capture is known, but some recordings have resisted full explanation. The bloop, a powerful, ultra-low frequency sound recorded in 1997, detected across multiple stations simultaneously, was louder than any known biological source. Subsequent analysis has suggested it may have been an icequake, but the investigation itself revealed how little of the ocean's acoustic life had been catalogued. The ocean still produces sounds we haven't identified. It is still telling us things we haven't understood. Not every voice in the world has been named yet. That is not unsettling. That is the honest condition of living in a universe larger than our current vocabulary. Ancient stories from across the Pacific describe waves that came without warning and changed the coastline. In Japan, Indonesia, the Philippines, the Pacific Islands, coastal South America, the Pacific Northwest, wherever people have lived beside the sea for thousands of years, there are stories. They share certain features across all those distances and all those languages. The sea pulling back, the wave arriving, the land changed, people who ran uphill surviving, people who did not surviving. Some of these accounts match, when cross-referenced with geological records, real events measurable in the sediment and the rock. Someone witnessed something and told someone else. Who told someone else? Who told someone else? Across centuries, across languages, across the whole long chain of people caring enough to pass something forward. You are the end of a very long chain of people who kept going. Right now, your body knows how to be still even when your mind does not. Beneath the surface of thought and the day's accumulated noise, your autonomic nervous system has been managing the transition to sleep since the moment you lay down. It knows how to lower your heart rate, how to release the tension in your shoulders, your jaw, the small muscles around your eyes, how to slow your breath and deepen it and shift it toward the long, easy pattern of sleep. It has done this every night of your life, thousands of times. It does not need instruction. It needs only the absence of interference, the quiet signal that it is safe to proceed. The deep ocean is barely touched by the storms at its surface. You have depths like this too. Let the automatic, faithful part of you take over now. It knows the way. The longest tsunami ever measured in travel time crossed the Pacific in less than a day, and almost no one noticed. Not 22 hours of drama, 22 hours of ordinary life continuing above it. People slept and woke on the shores it was approaching. Children went to school. Fishermen went out and came back. The The sun moved across the sky in its usual way, indifferent to the pressure wave crossing the ocean below it. The wave was recorded by instruments, understood by scientists, and the people on the far shore had time, a little more time than they would have had without the sensors, without the satellites, without the patient decades of work that made listening possible. Something enormous moved quietly through the world, and because people were paying attention, other people were safer. Bioluminescent plankton can make the water glow when a wave disturbs them. On warm nights near certain coastlines, breaking surf glows faintly blue-green dinoflagellates, microscopic organisms, flashing light when jostled. Each flash lasts less than a second. Together they make the wave visible in the dark, in a way it isn't in daylight. Not white foam but cold living light, moving up the shore and retreating. Witnesses to certain tsunami events have described an unusual luminescence arriving with the surge. The sea briefly glowing as it came. Not a warning, not intended for anyone, just the ocean's own chemistry, made briefly visible because something large passed through and moved what was living inside it. The world lights up when it is moved, sometimes in ways no one planned for. In many Pacific languages, the word for wave holds arrival and departure in the same breath. In English, a wave comes and then goes, two separate acts, the coming more named, more present. In some Polynesian and Melanesian traditions, the wave is a single continuous motion, one word, one event with two phases, neither more real than the other. This is physically accurate. The crest and the trough belong to the same wave. The rise and the fall are one unbroken movement, the water doing a single thing from beginning to end. The things that enter a life and then leave, perhaps they too are more honestly held, as one continuous motion rather than two separate losses. The coming and the going, one thing. The wave does not leave. It completes. Every coastline is still being shaped right now by water, not only in storms. In the ordinary work of every tide, each rise lifting grains of sand, dissolving trace minerals from rock, moving small things in and out of coastal marshes. That small work, twice a day, every day, across thousands of years, produces the coastline as it currently is, not fixed, not finished, always in the middle of becoming what it will be. The coast doesn't apologize for changing. It simply continues, responding faithfully to what arrives. You are also still being shaped. The same slow, patient forces, the things that come and the things that go, are still working on you. That is not incompleteness. That is how everything real is made. You are mostly empty space, and yet here you are, solid and warm and entirely present. If a hydrogen atom were expanded to the size of a cathedral, its nucleus would be no larger than a grain of rice at the center. Everything else, empty. The solidity you feel beneath you right now is not solidity in any absolute sense. It is electromagnetic force. Electron clouds refusing to overlap. The universe maintaining a boundary that your nervous system reads as something to rest on, and it holds, completely, without effort, without fail. The almost nothing is enough. It has always been enough. The forces holding you together are the same forces holding the ocean together. The same ancient rules, applied at every scale, to everything. You are as real as anything in the universe has ever been. The ocean contains not one perfectly still molecule of water. At the atomic scale, even the coldest, deepest water holds molecules moving at hundreds of meters per second, colliding billions of times each second. Above that, the currents move, the tides pulse, the deep circulation turns its thousand-year loops. Waves cross the basins, the bioluminescent creatures flash and go dark. At every scale simultaneously, from the molecule to the ocean basin, the water is doing something. And somehow, in all of that motion, there is peace. Motion and stillness are not opposites. The deepest calm is not the absence of movement. It is movement so vast and continuous it becomes, to the creature resting within it, indistinguishable from stillness. The ocean never stops, and it is one of the most peaceful places the mind can go. The Earth's interior is still cooling from the moment of its formation. The heat came from the collision of countless smaller bodies, and from the decay of radioactive elements in the rock. Over billions of years, it has been slowly escaping, conducted upward through the crust, carried by the convection of the mantle, released at volcanoes and ridges, and hydrothermal vents. That heat drives plate tectonics, the moving plates, the earthquakes, the tsunamis, all of it, ultimately powered by warmth left over from the birth of the planet, 4.5 billion years ago. The warmth beneath your feet tonight is ancient. It is the memory of a collision. The planet has been exhaling it since before it had an ocean, before it had a moon, before it had anything alive on its surface. You are resting on a slow fire. It is very old. It is very patient. It is not going anywhere. The ocean has recorded sounds that scientists have not fully explained. Hydrophone arrays originally deployed during the Cold War have been listening to the deep ocean for decades. Most of what they capture is known earthquakes, whale calls, the noise of ships. But some recordings resist full explanation. Low-frequency signals of unusual origin, detected across multiple stations, studied carefully, assigned tentatively, but not with certainty. The ocean still produces sounds that haven't been fully identified. It is still, in this literal sense, saying things we haven't yet understood. Not every voice in the world has been named. That is not frightening. It is the honest condition of living in a universe that is larger and older and stranger than our current vocabulary. The unnamed is not the unknowable. It is simply where the next understanding begins. Someone, a long time ago, told a story about what the sea had done so that someone they would never meet might survive it. Across the Pacific, across the Indian Ocean, across every coastline where people have lived, beside the water long enough to witness what it occasionally does, stories were told, carefully, repeatedly, to children who would tell their children. The sea pulling back, the wave arriving, run to high ground, do not go down to look at the fish. Some of those stories survived long enough to match geological records centuries later. The telling was faithful enough, across all that time, to still be accurate. Someone witnessed something and chose to pass it forward, not for recognition, not knowing if it would survive, simply because they understood that the people coming after them would need to know. You are the end of a very long chain of people who kept going, and kept caring, and kept passing things forward. Tonight, the sea is somewhere doing what it has always done. Let them drift away from you the way kelp drifts, in a slow current visible for a moment, then gone into the blue. What remains is simpler. You are here. You are breathing. The air entering your lungs was made, in part, by the ocean, by phytoplankton doing their quiet work in surface water far from here, releasing oxygen that traveled through the atmosphere and arrived, tonight, in this room, in this breath. The water in your cells was once rain. Before that, ocean. Before that, a river, a glacier, a comet traveling silently through the outer dark before falling to a young and cooling Earth. The hydrogen in that water is nearly 14 billion years old. It has been part of the universe longer than any star currently burning. And right now it is in you, warm, alive, at rest. Outside, wherever the nearest water is, a river, a harbor, a puddle reflecting the night sky, it is moving. Slowly or quickly, it is part of the same circulation that has been running since before your species existed. The tides continue. The deep currents turn their ancient loops. The pressure sensors on the ocean floor listen in the dark. The phytoplankton make their oxygen. The whales call across basins too wide to imagine. The world is tended, not by anyone in particular, by all of it, together, the physics and the biology and the patient, ongoing work of a planet that has been doing this for an almost incomprehensible length of time. You do not need to tend it tonight. Feel the weight of your body, the specific, particular weight of you, here, now held by whatever surface is beneath you. That surface is held by the floor, which is held by the building, which rests on rock that goes down for miles before it reaches the slow, hot, moving mantle of the earth. You are supported by something very deep, something very old, something that has been holding things up since long before there was anything on the surface worth holding. The earth has you. It has always had you. Every night of your life, you have given your weight to it, and it has held you without effort. Let yourself be held now. Your breath is slowing. Not because you are making it slow, because the part of you that knows how to rest is taking over from the part of you that has been managing the day. The automatic body, the ancient, faithful body. The one that has done this every night since you were new to the world. Somewhere, a wave is arriving at a shore. Quietly, the last act of a journey that began far away and long ago, spending itself in the soft hiss of foam on sand, and then returning slowly, gently to the water it came from. The wave arrives. It rests. It returns. You have traveled a long way tonight too, through facts about the deep and the dark and the fast and the slow, through stones that remember, and senses that listen, and stories that crossed centuries to reach the people who needed them. All of it pointing, quietly, to the same thing. That the world is larger than any worry, that the forces moving through it are older than any fear, that you are made of the same ancient material as everything else, hydrogen forged at the beginning, oxygen made in stars, water delivered across the dark, life assembling itself from all of that and finding, over 4 billion years, an almost infinite number of ways to continue. You are not separate from this. You have never been separate from this. The ocean is breathing. The moon is pulling at the water, gently, as it always has. The deep currents are moving in their ancient loops. The pressure sensors are listening, and you are here, warm, breathing, held by the same forces that hold the sea. The wave completes. The water gathers. The deep goes still, and you, for now, are also still, gently, quietly, ancient and new at once. I hope you sleep well and dream softly. Good night.